everyone. What's up, dear ones? A very good evening, all of you over here. And yes, it's me, your Rakhi ma'am, for this particular session, wherein today we are going to talk about the 12 most important questions of structure of atom. Hello, Mr. Jack Sparrow. Good evening. Hi, Mr. Vamsi. Good evening. Hello, Sajal. Good evening. Hi, Mr. Gaming. Good evening. Hi, Pranav. Good evening. Okay. Well, I believe that I am audible and visible to all of you over here. Yes, of course. Hi, Mr. Aakash. Good evening. Welcome to the session. So, how are you all? I believe that all of you are in your good health. Is that so? So, let's actually check that out. And I believe that today you are going to rock the session. I mean to say each and every answer will be given by you and that too correct. Hi Dharti, good evening. Hello Vicky, welcome to the class, welcome to the session. So, ready, steady, go for this particular session. And yes, I believe at 3 p.m. today we were having one short series for structure of atom. And that session was taken by Ajit sir. So I believe that you might have revised all the formulas which pertains to this particular chapter. Isn't it? Yes. So here, at this particular point, at this particular time, I am with the questionnaire of that particular chapter. Is that so? चलिए, बहुत जल्दी सी देखिए, introduction तो बनता ही है because there may be students who are new to this particular I'll say platform. So I need to give the introduction. So it's me, Rakhi, your mentor for this particular session, and I'm going to talk about the structure of atom, the 12 most important questions. Okay, well, before you go ahead, just please hit the like button, subscribe the channel, and yes, share this particular session among your friends. But before I move ahead, I just want to ask you one particular thing. That is your JEE preparation becoming overwhelming? Okay, do you need an expert guidance on how you should learn and practice? Yes. Are you losing the track of your progress and the areas of improvement with such a huge syllabus? Yes, ma'am. Okay, then what to do? See, we are actually introducing the Aakash app for JEE preparation. That's cool. Your one-step solution for the examination preparation journey. Fine. And the particular app, it comes with plenty of unique features, as you can see over here, that you are actually going to get what? For example, if I just talk about this particular app, it actually helps you achieve your mastery over the concepts you feel that they are very, very complicated. How come? Through the creative animated videos, and these animated videos, they are going to actually help you visualize and understand the concept. Fine? Okay. So, I'll just say that the link of this particular app has been given in the description box. Click there, explore it, and enjoy your learning. Fine? Yes, Miss Ratna Banerjee will be starting the class very fast. Need not to worry. Hello, Mr. Kamal. Hi Preetham, good evening. So let's start now without any delay for this particular session. And here I am with the very first question. And the question is the ground state energy of hydrogen atom. The ground state energy of what? The hydrogen atom. Okay, is minus 13.6 electron volt. The energy of second excited state of helium ion, He positive ion in electron volt is what? Okay. Chaliye, no issues, Mr. Ansari. But it would be better that you watch me live over here and solve the questions along with me. So I'm getting the answers as that. It's Preetham who's saying it's option number A. Captain Jack Sparrow says option number A. Gaming says it's option number D. Sir Shravan says it's option number D. Hanji. So option number D ko ya A ko kisko lock kiya jaye? Just let me know. I believe, yes, see, I'm getting two answers. It's option number A and option number D. Well, I'll say that it's option number A, the right answer. Yes, of course, the right answer is option number A, minus 6.04 electron volt. चलिए calculate करते हैं. मैम आपने कल के होमवर्क के आंसर्स देखे? Actually, you haven't given me the answers of the homework questions, the 3 homework questions. You haven't reported in the comment box. You haven't actually given me in the chat box. I was actually looking for that particular thing only. Okay, but today, by the end of the day, I'll be giving you the answers of those questions. Not to worry. Herein, we'll be talking about this particular question. So, the ground state energy of hydrogen atom has been given to us as minus 13.6 electron volt. We need to talk about the energy of second excited state of He positive ion in electron volt. Absolutely, yes. तो यहाँ देखिए, अगर मैं बात करती हूँ energy of electron in nth Bohr orbit. चलिए, we know that energy of what? Energy of electron in nth Bohr orbit. ये सभी को पता है इसका फॉर्मूला क्या होता है? It's actually minus 13.6 z स्क्वायर अपॉन n स्क्वायर इलेक्ट्रॉन वोल्ट. ये तो सभी को पता है कि नहीं? यस मैम, ये सभी को पता है. अब जो हमारा ग्राउंड स्टेट होता है, फॉर द ग्राउंड स्टेट n की वैल्यू क्या होती है? ग्राउंड स्टेट मतलब वी आर टॉकिंग अबाउट एनर्जी लेवल n equals to 1. Okay, so ground state is n equals to 1, and if I just talk about the second excited state. ओके, तो सेकेंड एक्साइटेड स्टेट क्या होगा? सेकेंड एक्साइटेड स्टेट मीन्स, सेकेंड एक्साइटेड स्टेट का मतलब है, इट मीन्स दैट द वैल्यू ऑफ एन, एनर्जी लेवल कौन सा होगा? थर्ड होगा. ठीक है, इट विल बी द थर्ड ऑर्बिट. यस, एब्सोल्युटली फाइन. सो यहाँ पर मुझे निकालना है एनर्जी ऑफ सेकेंड एक्साइटेड स्टेट E3, विच विल बी देन इक्वल्स टू माइनस 13.6 z स्क्वायर अपॉन n स्क्वायर. So Z है हमारा एटॉमिक नंबर. हीलियम का एटॉमिक नंबर कितना है? 2. So it will be 2 square upon n square 3 square. Okay, so solve it. Minus 13.6 into 4 by 9. ये होगा. ठीक है, so it's 9 ones are and it will be 1.5. Okay, क्लियर है ये वाली चीज. सो आपका जो अप्रोक्सीमेट आंसर जो यहाँ आने वाला है, इट विल बी 6 माइनस 6 इलेक्ट्रॉन वोल्ट. तो उसके नजदीक वाला आंसर कौन सा है? इट इज ऑप्शन नंबर ए, माइनस 6.04, माइनस 6.04 इलेक्ट्रॉन वोल्ट. ये आपका एक्यूरेट आंसर है. अप्रोक्सीमेशन से आंसर कैलकुलेट कीजिएगा, आंसर आपके सामने होगा. इट्स ऑप्शन नंबर ए. यू आर गोइंग टू मार्क इट, एंड यस, द स्टूडेंट्स हैव गिवन मी द आंसर एज ऑप्शन नंबर ए. एब्सोल्युटली राइट. वेरी गुड, गुड अप. I mean to say, keep up the good work. So chaliye, let's move ahead and let's talk about the next question in front of you, and here it is. The question is about the work function. आज की क्लास में वन शॉट सीरीज में आपने वर्क फंक्शन के बारे में पढ़ा होगा. हाँ जी, ज्योति कह रही हैं. Okay, Mr. Aditya is saying that explain it again, ma'am. Why? What's the need to explain it again? It was a simple formula we applied. Helium का हमें atomic number पता करना था, and second excited state n is equals to 3 था. That's absolutely it's actually very easy to understand. So, Mr. Aditya, just have a look. First of all, you need to know the formula. Then the second excited state क्या होगा, and then put the values in the formula and get your answer. Fine. चलिए, अब इस question के बारे में पढ़ते हैं. What is the work function of the metal? What is the work function of the metal if the light of wavelength 4000 angstrom generates photoelectrons of velocity 6 into 10 raised to power 5 meters per second from it? We need to talk about the work function of the metal if the wavelength of the light 4000 angstrom, it's actually generating the photoelectrons of the velocity 6 into 10 raised to power 5 meters per second from it. We have been given with few particular terms: mass of electron, velocity of light, Planck's constant, charge of electron. So what will be the work function? Now what do you mean by work function? We represent this work function by this phi. And it's actually the minimum energy required to eject an electron out of the surface of metal. Okay? So, work function is basically what? The minimum energy required to eject an electron out of the surface of the metal is known to be as work function. Okay. So, there is an expression wherein it's EI is equals to work function plus kinetic energy. incident energy is actually equals to work function and kinetic energy. Work function I explained you just now, and kinetic energy is the energy to move the electron. Okay, move the electrons, absolutely right. So work function phi is equals to incident energy I minus of kinetic energy. Okay, so your incident energy EI is equals to h nu, okay, minus half mv square. Yes, absolutely fine. Okay, substitute the values and get your results over here. Okay, so phi is equals to, phi is actually, that is the work function is equals to h nu. What is h basically? And yeah, before that, nu is equals to c by lambda. Okay, so h is 6.626 into 10 raised to power minus 34 multiplied by what? Speed of light, c, which is 3 into 10 raised to power 8. Okay, divided by wavelength that has been given to us as 4000 angstrom, changing it into meters. So 1 angstrom is equals to 10 raised to power minus 10 meters. So over here it is 4000 multiplied by 10 raised to power minus 10 minus half of, it's actually the mass of electron, which has been given to us as 9 into 10 raised to power minus 31 kg. 9 into 10 raised to power minus 31. V square, it's actually given to us velocity of light. Okay, wavelength 4000 angstrom generates photoelectrons of velocity. Okay, so it's been given to us, and that is what it is, 6 into 10 raised to power 5 whole square. Solve this now. बहुत गंदा and weird expression आया, but need not to worry, we will be solving it out. So over here what we are actually going to get is, just listen to me very carefully, it's 6.6 we can take into 10 raised to power minus 34 plus 8, okay, plus 10, okay, fine, and minus 3, and it will be minus 3, fine, divided by, so multiplied by 3 over here, and it is 4 over here. So 6.6 into 3 makes it 19.8 divided by 4 into 10 raised to power, how much will it be? 10 raised to power, how much it is gonna be? Just have a look. So it's 34, okay, and it's 3, 37. So we have 37 minus 37 and 18 over here. So what it will be, any idea? It will be 19. It will be 19 into 10 raised to power minus 19. Okay. So over here 4 ones are, and it will be then 4.95. Okay. So in a way we are having 4.95 into 10 raised to power minus 19. 4.95 into 10 raised to power minus 19. Keep it as it is. Now we will be solving this particular expression. Minus 1 by 2. Okay. Minus 1 by 2 into 9. Okay. Into 36 into 10 raised to power minus 31 plus 10 over here. Is the thing clear to you? Is this particular thing clear to you? Now it will be 10 raised to power minus 21. Minus 21. 2 ones are and 2 18s are. Okay. And 18 nines are 162. So it will be 162 into 10 raised to power 10 raised to power minus 21. And I can write this 162 as 1.62 into 10 raised to power minus 19. So in a way it's 1.62 into 10 raised to power minus 19. We'll take 10 raised to power minus 19 common. So it's 4.95 minus 1.62. What will be your results? This answer is going to come in joules. This answer is going to come in joules. Okay. So it will be how much? It will be 3.33 into 10 raised to power minus 19 joules. And if I just talk about 1 electron volt is equals to 1.602 into 10 raised to power minus 19 joules. So what we are going to do is we will be dividing this particular expression with 1.602 into 10 raised to power minus 19, and it will be in electron volt. This cancels out with this basically. So when you solve this out, take it as 3.3 divided by 1.6 approximation. Your result for this will be, your answer will be 2.07 electron volt. This will be your answer. Yes, this will be your answer. So 2.07 electron volt, and that is actually approximating to option number C. So option number C is the right answer. Option number C बिल्कुल सही आंसर है. ठीक है, क्लियर है? ओके, प्रीतम आप उसको भी यूज कर सकते हैं, बट सिंस वी एक्चुअली वांट द आंसर टू बी, ठीक है, आप उसको यूज कर सकते हैं जो आपने वैल्यू बताया है. दैट्स एब्सोल्युटली फाइन इन इलेक्ट्रॉन वोल्ट, वो भी हम डायरेक्टली यूज कर सकते हैं. फाइन, दैट्स नो इश्यूज इन इट. ठीक है, सो यहाँ पर we did this particular calculations and it's 2.07 electron volt, which is basically 2.1 in the given options. Option number C is right. Okay, you can go ahead with this, Preetham, if you want, since ये भी हमारा electron volt के अंदर ही आता है, so you can go ahead with this. ठीक है, चलिए, let's talk about the next question in front of you. The number of subshells associated with n is equals to 4 and m equals to minus 2 quantum numbers is what? हाँ जी, बताएंगे इसका आंसर आप मुझको? हाँ जी, just let me know. क्या कहेंगे इसके बारे में आप? The number of subshells associated with n equals to 4 and m equals to minus 2 quantum numbers is what? इसका क्या आंसर होगा? What will be the right answer? Preetham, you say it's option number A, that is 4. That means you are saying there will be 4 subshells associated with principal quantum number 4 and magnetic quantum number minus 2. Is that so? Just check this out if you are not making a mistake. It's m equals to minus 2 we are actually going to talk about. So let me help you out for this particular question. ध्यान से सुनिए and देखिए what I actually want to say. See, for n equals to 4, for n is equals to 4, we know that L की जो value होती है, it's L equals to 0 to n minus 1. So your value of L will be 0 to 3. That means it will be 0, 1, 2, 3. So these are the subshells. S subshell, it's P, it's D and it's F basically. Captain Jack Sparrow, अनिकेत ने बिल्कुल सही आंसर दिया है. It's option number C. 2 होगा. There will be 2 subshells associated with the quantum number, principal quantum number n equals to 4 and magnetic quantum number m equals to minus 2. ठीक है? Fine. Is this clear? Let me help you out for this. Now, magnetic quantum number ml, if I just talk about ml, magnetic quantum number ml, it do have values from minus L to plus L. Okay, and a total of, and what? A total of what? Total of 2L plus 1 values. Total of 2L plus 1 values. So, if I just talk about for L equals to 0, ml will be equals to 0, isn't it? Isn't it? Yes. And for L equals to 1, ml की value क्या होगी? It will be minus 1, 0 and plus 1. Okay. For L equals to 2, ml की value क्या होगी? It will be minus 2, minus 1, 0, plus 1 and plus 2. Okay. And for L equals to 3, ml की value क्या होगी? Minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. 1 minute, plus 1, plus 2 and plus 3. ठीक है. So for m equals to minus 2. ठीक है. Okay, fine. So when L is equals to 2 and L is equals to 3. Okay, so this is our D subshell. For L equals to 2, it means we are talking about D subshell. D subshell, okay, this is D subshell, and for L equals to 3, it means it is F subshell. It is F subshell, okay. We want the number of subshells that are associated with n equals to 4 and m equals to minus 2. So we are having minus 2 here in these two cases. When L is equals to 2 and L is equals to 3, we do have ml equals to minus 2 over here in both the cases. So D and F subshells, these two subshells are associated with n equals to 4 and m equals to -2 quantum number. So we'll go ahead with option number C and yes. Yes, only in D and F. Absolutely right. So it's option number C, the right answer for the question asked for. Chaliye, let's move ahead and let's talk about the next question. Okay, the region in the electromagnetic spectrum, the region in the electromagnetic spectrum where the Balmer series line appears is, the region in the electromagnetic spectrum, the region in the electromagnetic spectrum where the Balmer series lines appear is. So yes, it's obviously the straightforward answer, and it's option number C, the right answer. Visible region hoga. Yes. So if I just talk about Lyman series, Balmer series, okay, then Paschen series, fine, bracket series, fine, and it's P-Fun series, fine. So you can just go with this particular thing, U, V, I, and I. Fine. So for these particular series, if I just talk about, इनकी wavelength एक particular region में lie करती हैं, and उन region को absolutely हमें याद करना होगा. So the wavelength of spectral lines of the Balmer series. Wavelength of what? Spectral lines of which particular series? Balmer series. It actually range between 400 nanometer to 780 nanometer. ठीक है? And it is in the range of wavelength of visible light. Yes. Yeah, of course, बिल्कुल आप बात सही कह रहे हैं. One can easily go ahead with this particular thing. So Balmer series lie in the visible light region. Option number C is the right answer. इसमें कुछ भी बहस करने वाली या चर्चा करने वाली की बात नहीं है. Now let's talk about the next question. Here it is. Yeah, it's a good question. Please give the time to this particular question too. The correct statement about probability density, except at infinite distance from the nucleus is. Okay, so आपको इसका आंसर मुझे बताना होगा. Yes, the correct statement about probability density except at infinite distance from nucleus is. So Ronak says it's very easy. Acha, previous one was very easy. This particular question is also very easy. So today Astha is present in the class. Welcome Astha. So you say that it's option number A, the correct statement about probability density. It can never be 0 for 2s orbital, it can be 0 for 3p orbital, it can be 0 for 1s orbital, it can be negative for 2p orbital. हाँ जी, क्या कहना चाहेंगे आप इसके बारे में? What you are going to actually talk about for the same? So it's option number C, option number B, option number A. चलिए हम इसकी जो चर्चा है ग्राफ्स के थ्रू करते हैं. ठीक है, यहाँ पर वी आर गोइंग टू टॉक अबाउट द रेडियल नोड्स, एंड वी ऑल नो कि जो रेडियल नोड्स होते हैं, डियर वंस, इट्स एक्चुअली इक्वल्स टू n माइनस l माइनस 1. ये फॉर्मूला होता है. तो अगर इफ आई जस्ट प्लॉट द ग्राफ, ओके, इफ आई जस्ट प्लॉट द ग्राफ, वेट अ मिनट, बिटवीन xi स्क्वायर, ओके, बिटवीन xi स्क्वायर, फाइन, एंड r. Okay, clear है ये? Fine. So in a way I'm just talking about the probability density versus the distance r, distance from nuclei. So if I just talk about for 2s orbital, what you are going to see is for the 2s orbital, you will actually see this particular kind of a graph. You are going to see this particular kind of the graph. ऐसा कुछ आपको देखने को मिलेगा for 2s orbital. Fine. So over here at this particular point, if I just talk about xi square is actually equals to 0, we can just talk about the same. Yes, ma'am, we can just say. See, if I just talk about 2s, okay, orbital, number of radial nodes will be, if I just talk about the radial nodes, it's basically 2 minus 0 minus 1, which is equals to 1. One radial node will be there. That's absolutely being seen over here. Fine. Well, if I just talk about for 2p orbital, के बारे में बात करते हैं. So a graph plotted between xi square and the r. So herein what you are actually going to see, this is what we are going to see. Okay, it's for 2p, and the radial nodes for 2p, if I just talk about, it will be 2 minus 1 minus 1, which tends to 0. So for 2p, probability density, if I just talk about, can it be 0? For 2p, probability density can be actually equals to 0. यहाँ इस particular point पे we can see. Fine. Let's talk about 3s orbital. अगर मैं 3s orbital के बारे में बात करती हूँ and plotted the graph between xi square and the r. So what you are going to see is this, okay, then this kind of like this structure you are going to see. I may not be drawing it properly, but yes, kind of like this only you are going to get. So this. So for 3p, if I just talk about the number of radial nodes के बारे में अगर बात करते हैं, so it's 2 minus, it will be 3 minus 1 minus 1. Okay, 3 minus 1 minus 1. So it tends to, no, it's for 3s basically. It's for 3s. I'm sorry. So it will be 3 minus 0 minus 1, which is equals to 2. So एक तरह से दो radial nodes के बारे में हम यहाँ पर चर्चा कर रहे हैं. Fine, that's absolutely right. Yeah, absolutely right. हाँ जी. अर्पिता, मैं एक्सप्लेन ही कर रही हूँ ये सारी चीजें. These are the graphs you need to learn कि हाँ भाई इस तरह का ग्राफ होता है between xi square and the r for 2s, for 2p, for 3s. ठीक है, ये हमने 3s के बारे में बात कर ली है. अगर मैं 1s के बारे में बात करूँ, if I just plot the graph of 1s between xi square and the r, what you are going to see is like this. You are going to see for 1s इस तरह का आपको कुछ मिलेगा. और यहाँ पर जो रेडियल नोड्स हैं फॉर 1s, इट्स 1 minus 0 minus 1, which is equals to 0. Okay, so for 1s it can never be 0. Okay, याद रखिएगा जो xi square होता है, it is always greater than 0 and it can never be negative. It can never be negative. ठीक है, तो अब यहाँ पर देखते हैं करेक्ट स्टेटमेंट अबाउट प्रोबेबिलिटी डेंसिटी. ओके, एक्सेप्ट एट इनफाइनाइट डिस्टेंस फ्रॉम द न्यूक्लियस, उसको हटा के प्रोबेबिलिटी डेंसिटी की बात करते हैं. सो इट कैन नेवर बी 0 फॉर 2s ऑर्बिटल. Okay, is this particular statement true? It can never be 0 for 2s orbital. Okay, if I just talk about for 2s orbital, so yes, if I just talk about, it can never be 0. For 2s, it can be 0. For 2s, it can be 0. Can you just see over here? It can be 0 for 2s orbital. Probability density can be 0 for 2s orbital. We do have a radial node 1. What are nodes? Nodes are a point wherein the probability density of finding an electron is basically 0. So for 2s, it can be 0. Absolutely right. So yes, it can never be 0 for 2s orbital. It's actually the false statement. Talking about B statement, it can be 0 for 3p orbital. It can be 0 for 3p orbital. Fine. अच्छा. It can be 0 for 3p orbital. So अगर मैं 3p orbital के बारे में बात करती हूँ, and if I just talk about its radial node for 3p basically, so it's 3 minus 1 minus 1, so it comes out to be 1. तो यहाँ पर आप देखिए 3p के लिए we'll say it can be 0 for 3p orbital. It's actually the true thing. It can be 0 for 1s orbital. 1s orbital के बारे में मैंने आपको यहाँ दिखाया. It can never be 0 for 1s orbital. 1s orbital के लिए it can never be 0. So it is a false statement. यहाँ पर आएगा cannot. It cannot be 0 for 1s orbital. Absolutely right. Well, if I just talk about, it can be negative for 2p orbital. For 2p orbital, I'll just say we can have a density, it can be 0. But saying it can be negative for 2p orbital, always remember that probability density xi square is always greater than 0. It can never be negative. Okay, it can never be negative. So it's a false statement. What we want to talk about, option number B, that's absolutely right. Any doubt to anyone, just let me know. Anyone having any doubt for this particular explanation, just let me know. Here it is. यहीं पर ही मुझे बता दीजिए. चले? Okay. Fine. हाँ जी, no doubt. चलिए, let's move ahead. Preetham, that is what I was saying. I'm talking about xi square, not about xi. Okay, I'm talking about xi square basically. So it can never be negative. चलिए इस क्वेश्चन के बारे में बात करते हैं. Let's talk about this particular question. So the number of electrons associated with quantum numbers n is equals to 5. n is equals to 5. Just let me know. हाँ जी, इस क्वेश्चन के बारे में बताएं, क्या कहेंगे आप? Yes, let me know. Come on. Number of electrons that is associated with quantum numbers n is equals to 5 and spin quantum number, magnetic spin quantum number equals to plus half. क्या बात है आकाश? Very good, absolutely right. Option number C, रटा रटाया क्वेश्चन है कि नहीं? So yes, it's option number C the right answer. 25 is the right answer. बिल्कुल सही बात. Number of electrons associated with quantum numbers n is equals to 5 and it's actually 25. ठीक है, clear है. जैसा कि आकाश ने कहा, just make it a square. Okay. Well, simply यहाँ पर मैं आपको एक बात बताना चाहती हूँ. ms is equals to half है. एक थोड़ा सा explain कर देती हूँ. ms is equals to half है. Spin quantum number, magnetic spin quantum number half है. That means it's clockwise we are actually going to talk about. Only half spin के बारे में हम बात करेंगे. तो n equals to 5 के लिए L की वैल्यू क्या हो जाएगी? 0 to 4 हो जाएगी. So how many subshells we have? 0, 1, 2, 3 and 4. S, P, D, F हो गया. So total number of orbitals इनमें कितने हैं? इसमें कितने number of, अगर मैं orbitals की बात करती हूँ, total number of orbitals in these subshells की अगर मैं बात करूँ, so it's 1 plus 3 plus 5 plus 7 plus 9 जो कि है 25 ऑर्बिटल्स. और 25 ऑर्बिटल्स में अगर मैं बात करती हूँ प्लस हाफ स्पिन की, तो 25 इलेक्ट्रॉन्स होंगे, है कि नहीं? यस. सो यहाँ पर इट्स ऑप्शन नंबर सी द राइट आंसर टू द क्वेश्चन आस्क्ड फॉर. चलिए लेट्स मूव अहेड एंड लेट्स टॉक अबाउट द नेक्स्ट क्वेश्चन हियर इन विद यू गाइज. सो यहाँ पर वी आर एक्चुअली गोइंग टू टॉक अबाउट द डी ब्रॉगली वेवलेंथ. द डी ब्रॉगली वेवलेंथ ऑफ एन इलेक्ट्रॉन in the fourth Bohr orbit is. In the fourth Bohr orbit. चलिए बताएं आप मुझे. The de Broglie wavelength of an electron. The de Broglie wavelength of an electron in the fourth Bohr orbit. In the fourth Bohr orbit. क्या बात है आकाश? Absolutely right. 8 pi a naught is the right answer. अगर मैं डी ब्रॉगली वेवलेंथ की वैसे बात करती हूँ, so we know that lambda is equals to h upon mv की हम यहाँ बात करते हैं, ठीक है. लेकिन अगर इसका मैं एसोसिएशन कर दूँ डी ब्रॉगली प्रिंसिपल का with the Bohr orbit, we know that mvr is equals to nh upon 2 pi. ये हमें पता है कि नहीं पता है? यस मैम, ये तो हमें पता ही है. ओके, नाउ यहाँ से देखिए 2 पाई आर इज इक्वल्स टू एन एच अपॉन एम वी होता है एंड एच अपॉन एम वी हमारा लेमडा है. सो मैं इसको एन लेमडा कह देती हूँ. सो हेयर इन वी हैव डन द एसोसिएशन ऑफ डी ब्रॉगली प्रिंसिपल विद द बोहर्स मॉडल. With the Bohr's model. Absolutely right. Yes, yes. अब क्या करना है? There is nothing left. बस यहाँ तक हम जो पहुंच गए हैं, that's absolutely fine. What else we want to talk about over here is we want to talk about the de Broglie wavelength of an electron in fourth Bohr orbit. That means lambda is equals to 2 pi r upon n की हम यहाँ बात कर रहे हैं. Okay मैम. अब ये r क्या होता है? If I just talk about r is equals to a naught n स्क्वायर बाई z. ये a नॉट कॉन्स्टेंट है और इसकी वैल्यू क्या है मैम? इस a नॉट की वैल्यू क्या है? इट्स 0.529. ठीक है, क्लियर है? हाँ जी. सो यहाँ पर हम इसको सब्सटीट्यूट कर देते हैं 2 पाई ओके इंटू ए नॉट एन स्क्वायर अपॉन एन इंटू जेड. सो ये n से n कैंसिल आउट हो गया. सो वी आर एक्चुअली लेफ्ट विद दिस ओनली 2 पाई ए नॉट एन अपॉन जेड. अब क्या करना है मैम? Substitute the values and you will get the results, dear ones. अब कुछ भी नहीं बचा है. So fourth Bohr orbit है, that means n की वैल्यू 4 है आपके लिए. Okay, and by default we'll be considering कि भाई ये हम हाइड्रोजन एटम के लिए कर रहे हैं. So it will be 2 pi into a naught into 4 by 1 which comes out to be 8 pi a naught. ये है आपका आंसर. ऑप्शन नंबर डी इज द राइट आंसर. ऑप्शन नंबर डी इज द राइट आंसर. ठीक है, क्लियर है? डन 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 डन. कोई डाउट? कैप्टन जैक स्पैरो, आस्था, कार्तिक, प्रीतम, मिस्टर गेमिंग, जस्ट लेट मी नो. निरुपमा, आकाश, एनीवन, एनी काइंड ऑफ अ डाउट, जस्ट लेट मी नो. I hope there won't be any doubt to this particular question. Each and everything has been clear to you over here. Clear? Done, done. चलिए आगे बढ़े. Okay, no issues ma'am. चलिए, herein we'll be talking about the next question. ये तो बहुत theoretical question है. ये तो बहुत theoretical question है. So here it is. बहुत easy peasy lemon squeezy question है ये तो. Easy peasy lemon squeezy question है ये तो. इसमें तो I don't think कि आपको कुछ सोचना भी पड़ेगा. No, कुछ नहीं सोचना पड़ेगा. Amongst the following statement, that which was not proposed by Dalton was. Which was not proposed by Dalton. चलिए. Amongst the following statements, that which was not proposed by Dalton was. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. It's absolutely true. Matter consists of indivisible atoms. Absolutely right. ये Dalton ने propose किया था. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. हाँ जी, डाल्टन्स ने बोला था कि केमिकल रिएक्शन में देयर इज एक्चुअली द इन्वॉल्वमेंट ऑफ व्हाट, रीऑर्गेनाइजेशन ऑफ द एटम्स. एटम्स कैन नाइदर बी क्रिएटेड नॉट बी डिस्ट्रॉयड इन अ केमिकल रिएक्शन. ये भी डाल्टन्स ने कहा था. तो ये ए बी सी तो बिल्कुल यार सही है. डी के बारे में बात करते हैं. वेल, डी इज द राइट आंसर टू द क्वेश्चन. ये डाल्टन ने एक्चुअल में प्रपोज नहीं किया था. व्हेन गैसेस कंबाइन और रीप्रोड्यूस, when gases combine or reproduce in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. It was actually, it's basically the Gay-Lussac's law. It's actually, yeah, of course, बिल्कुल आकाश ने सही कहा. यहाँ तो एक तरह से you can say आप बहुत जल्दी eliminate out कर देंगे. यहाँ पर how can you talk about the temperature and pressure thing? ठीक है, it was a Gay-Lussac's law of combining volume of the gases. Gay-Lussac's law of combining volume of the gases, dear one. Okay. Yes, absolutely right आस्था, absolutely right. हाँ जी, तो इसमें तो कुछ सोचने की बात नहीं थी, but since question था तो मुझे पढ़ना था और आपको बताना था. That's the main thing. So here we go ahead and let's talk about the next question. And yes, tell me about this particular question now. The number of photons emitted by a monochromatic मतलब single frequency. The number of photons that has been emitted by a monochromatic infrared rangefinder of power 1 milliwatt and wavelength 1000 nanometer in 0.1 second is x into 10 raised to power 13. So the value of x is what? So the value of x is what? Very easy peasy lemon squeezy question. And even I believe ये question मैं already आपको करवा भी चुकी हूँ. I have actually explained this particular question. मैं करवा भी चुकी हूँ. ठीक है. So इसका आंसर क्या होना चाहिए? Just let me know. चलिए. We know that. देखिए यहाँ हमें power दी हुई है. We have been given with the power. Okay. Which is 1 milliwatt. Okay. Which is actually equals to 10 raised to power minus 3 watt. हम ये कह सकते हैं. Which means if I just talk about watt, it means 1 joule. Okay, it's joule per second. That means 10 raised to power minus 3 joules in 1 second. In 1 second. Hope you got it. So we do have 10 raised to power minus 3 joules of energy. Okay. We are actually having 10 raised to minus 3 joules of energy in 1 second. Therefore, we'll say it's 10 raised to power minus 4 joules of energy we are having in 0.1 second. Because we have over here given with 0.1 second, that's the thing. Okay. So 1 watt means it's 1 watt का मतलब है कितनी energy release हो रही है. 1 watt means 1 watt में we do have how much energy getting out? 1 joule per second. Okay. So it was 10 raised to power minus 3 joules in 1 second, which means it will be 10 raised to power minus 4 joules of energy we are having in 0.1 second. I hope that's absolutely right. अब यहाँ सीधा formula लगा दो. E equals to NHC upon lambda. Okay, nothing you have to do. So it's 10 raised to power minus 4 n into 6.6 into 10 raised to power minus 34 into 3 into 10 raised to power 8 divided by It's 1000 nanometers changing into meters. That means into 10 raised to power minus 9. So from here the value of n will be 10 raised to power minus 1. Why I'm writing 10 raised to power minus 1? 10 raised to power minus 4 multiplied by 10 raised to power 3. Okay, so 10 raised to power minus 1 into 10 raised to power minus 9, it makes it as, it's like this. So we can write it as 10 raised to power minus 10 divided by 6.6 into 10 raised to power minus 34. So I can write it as 6.6 into 3 into 10 raised to power minus 34 plus 8. Can I write it like this? Yes, ma'am. Of course, you can go ahead with this thing. So it will be 10 raised to power minus 10 plus 34 minus 8 divided by 19.8. Can I write it like this? Yes, ma'am. So it becomes 10 raised to power 16 over here divided by, let me write it like this only, 6.6 into 3, and over here also 6.6 into 3. Now what we can do, it's 10 raised to power 16 divided by 19.8. 19.8 ko how we can write? 10 raised to power 16 by 20. Can I write it like this? Yes, ma'am. So it's 1 upon 20 into 10 raised to power 16, which is 1 upon 2 into 10 raised to power 15, and 1 by 2 is basically 0.5. 0.5. Can I write it like this? Yes, ma'am, you can. Approximately 50. Absolutely right. Approximately 50. वैसे अगर हम यहाँ पर 19.8 करके देखते ना, जैसे 19.8 किया, 19.8 किया, यहाँ पर भी 19.8 चलिए, इतना हम जो कर रहे हैं, straight away यहाँ से यहाँ पर आ जाते हैं. So it will be 0.502 into 10 raised to power 15. ये आता हमारा आंसर. So यहाँ पर it would be 50.2 into 10 raised to power 13 कर देते. So हमारा approximately आंसर जो आया है वो 50 आया है. ठीक है? So उस हिसाब से it will be the value of x is equals to 50. Yes, absolutely right. बात सही. अनिकेत प्रताप सिंह 50 absolutely right. हाँ जी, absolutely right. चलिए, हो गया? Okay, fine. फाइन. चलिए, 50 is the right answer. अप्रोक्सीमेशन भी करेंगे तो वो 1/2 आ गया आपका. 0.5 into 10 raised to power 15 आ गया. 13 के टर्म्स में लेके जाएंगे 10 raised to power 13 के टर्म्स में. So it will be 50 into 10 raised to power 13 हो जाएगा. Done. Absolutely, मैम. बिल्कुल सही बात हमने कह दी है अब. और its answer is 50. चलिए, let's talk about the next question here. A 50-watt bulb. A 50-watt bulb emits monochromatic red light. A 50-watt bulb emits monochromatic red light of wavelength 795 nanometer. The number of photons emitted per second. The number of photons emitted per second by the bulb is x into 10 raised to power 20. The value of x is what? Again, a simple, easy peasy lemon squeezy question. So, we know that 1 watt is equals to 1 joule per second. Therefore, 50 watt is equals to 50 joules per second. And E is equals to, energy is equals to NHC by lambda. Substitute the values over here. So, it's 50. Okay, equals to N. What is H? 6.6 into 10 raised to power minus 34. What is C? If I just talk about C, okay, speed of light, which is 3 into 10 raised to power 8 divided by lambda. The value of lambda, it's nanometer. We'll be converting into meters because the value of C is in meters. So it's better to convert in meters ताकि easily we can actually get away with the units thing. Okay? Fine. So over here it will be 795 into 10 raised to power minus 9. Now what you have to do, solve this and you'll get the answer. So over here if I just talk about n will be equals to 50 into 795. 50 into 795 into 10 raised to power minus 9 divided by 6.6 into 10 raised to power minus 34 into 3 into 10 raised to power 8. Now you need to actually separate 10 raised to power minus values. Okay, so over here it will be 50 into, if I just take this 795 as 800, I'm going with the approximations, into 10 raised to power minus 9 plus 34 minus 8 divided by 6.6 into 3, and 6.6 into 3 is basically 19.8. So what we are actually going ahead with, so what it will be, 5 8s are 40 and 40,000 into 10 raised to power 17. Can I take this 19.8 as 20? Yes ma'am, you can go ahead. So this cancels out with this. 2 1s are and it's 2000s. Okay. So what it will be, 2 into 10 raised to power 20. So your answer to this particular question will be 2. And the value of x is 2. The value of x is 2. The value of x is actually 2. Okay, fine, absolutely right. Jack Sparrow, have done the same thing, need not to worry. I've done my part now. Okay, fine, no issues now. Chaliye, chaliye, chaliye. Absolutely right. Okay, so answer is 2. Cool? Yes, yes, yes. Okay, Asta, no issues. Oh, my pleasure, Mr. Karthik. And I believe that you will be enjoying tomorrow's session of thermodynamics. I'll make sure. Okay, fine. Chaliye, it's the answer 2 with us. Let's talk about the next question. The wavelength of electrons. The wavelength of electrons accelerated from rest through a potential difference of 40 kilowatt is x into 10 raised to power minus 12. Is the thing clear? Is the thing clear? Very soon, Asta, very soon. Need not to worry, very, very soon. Okay, fine. Chaliye, chaliye, chaliye. The wavelength of electrons accelerated from rest through a potential difference of 40 kilowatt is x into 10 raised to power minus 12 meter. Okay, fine. The value of x is what? So over here, we have been given with few particular terms: mass of electron, charge on an electron, Planck's constant. That's what the thing has been given to us. Thank you so much, Asta. That was a compliment you have given to me, and it's kind of a motivation for me. And if such a motivation comes around a teacher, the teacher brings more sessions kind of like that, isn't it? Yes. So over here, if I just talk about de Broglie wavelength of the electron, we know that it's basically h upon under root of twice of m, okay, and it's the kinetic energy which we are having with us. Fine? Okay. Now let me tell you one thing, and that particular one thing is electron is accelerated from rest. Electron is accelerated from x. So over here, kinetic energy, we can just take it as Q into V. Okay. We can take this kinetic energy as Q into V, charge on the electron multiplied by V. What is V over here we have been given with? I'll just make you understand each and everything. Need not to worry. Fine. The thing has been clear? Okay, fine. So over here, just substitute the values and you'll get the result. So it's 6.6 into 10 raised to power minus 34 upon under root of what? It's 2. The mass of electron 9.1 into 10 raised to power minus 31 multiplied by the charge on electron 1.6 into 10 raised to power minus 19. Clear? Okay, multiplied by V that has been given to us, okay, which is 40 kilowatt. 40 kilowatt, okay, fine. kV, okay, fine. So we can convert it into volt. 40 kilovolt to we can convert it to volt. So it will be 40 into 10 raised to power 3 basically. Okay, fine. Any issues? No issues. Now you have to do, it's such a weird expression, no, but we'll be actually solving this out. So it will be 6.6 into 10 raised to power minus 34. It will be then under root of what? It's 2 into 9. 9.1 I can take it as 9 and 1.6 I can take it as 2 multiplied by its 40 and it's 10 raised to power minus 31 minus 19 plus 3. I can go ahead with this particular thing. Okay. Yes. more I can do is plus 4 I can do over here. Yes, ma'am. So it will be 6.6 into 10 raised to power minus 34, and it is 2 9s are 18, 18 2s are 36. Okay, and 36 into 4 is basically 144. 36 into 4, 4 6 are 24, 4 to carry, and it's 144. Absolutely right. You have to take the approximation, otherwise it will be very much difficult to handle this out. So it will be 6.6 into 10 raised to power minus 34 divided by 12 into 10 raised to power minus 23. We'll take this 23 up in the numerator, plus 23. So 34 and plus 23, if I just make this particular thing ahead. So 4 minus 3 is 1 and 3 minus. So it will be minus 11. It will be minus of 11. 6.6 in 10 raised to power minus 11 divided by 12 we are having over here. So when we solve this, actually we get the answer approximately up to what? Yes, we can use direct formula also. Hanji, you can go ahead with this particular thing also. You can use the direct formula also. But in case, if you want to solve it like this, it's 0.58 into 10 raised to power minus 11, which makes it as 5.8 into 10 raised to power minus 12. So 5.8 and nearest integer, if we want to count out, let's make it as 6. So your nearest integer will be 6. So it will be 6, your right answer. Yes, Aniket, 6 is actually the right answer. Yeah, Karthik, you can go ahead with this particular thing also. Yeah. Take care. As suited by you, no issues. Whatever suits you, go ahead with this particular thing. Fine? Okay. Okay. Let's move on to the last question of the session. An accelerated electron has a speed of 5 into 10 raised to power 6 meters per second with an uncertainty of 0.02%. Fine. Over here we are going to talk about Heisenberg uncertainty principle. The uncertainty in finding its location while in motion is x into 10 raised to power minus 9 meters. The value of x is, we need to find out the value of x. Mass of electron has been given to us. Okay. And the Planck's constant value as well as the value of pi has been given to us. Absolutely fine. Any issues, just let me know. I don't think there would be any issues over here for this particular question. We over here are going to talk about the Heisenberg uncertainty principle. So according to this particular principle, as you all know, the position and the momentum of a moving particle cannot be actually accurately determined simultaneously. Fine. Okay. So we know that delta x dot delta p, okay, it's actually greater than equals to h upon 4 pi. Is the thing clear to you? Yes, ma'am. That's absolutely comfortably we know each and everything over here. Fine. So this delta x is basically the error in position, okay. And if I just talk about p, momentum is equals to mv. So delta p is equals to m delta v. Is the thing clear? Yes, ma'am. This is also clear. So delta v, if I just talk about it, is error in velocity, and delta p is basically error in momentum. Error in momentum. I mean the level and everything. Yes, you can expect. Asta, you can expect, because yeah, such questions do come. You can easily expect them. Yeah, of course. Fine. It's just you need to play smartly. Fine. You should be pro in the calculations basically. Okay. Done. So over here, if I just talk about delta V, the error in velocity, if I just talk about, it's basically 0.02 divided by 100 multiply with 10 raised to power, multiply with 5 into 10 raised to power 6 basically. So when you solve this out, you are going to get the answer as how much? It will be 10 raised to power 3 meters per second. So all this is very easy to solve. Okay, fine. So over here, delta x dot delta v is equals to h upon 4 pi m. This is what we know. Substitute the value. So it is basically x into 10 raised to power minus 9. X into 10 raised to power minus 9 has been given to us. Okay, multiplied by 10 raised to power 3 basically. Delta V is basically 10 raised to power 3 equals to h upon 4 pi m. So what is h? It's 6.6 into 10 raised to power minus 34 divided by 4 into 3.14. And what is the mass of electron, which is 9.1 into 10 raised to power minus 31. Now you can actually solve it. Okay, ma'am, if if in an integer type question my answer is coming approximately to be 5.5, and I can write it at either 5 or 6, will both be considered correct? Asta, over here, what should I say, यहाँ पर थोड़ा तो गड़बड़ हो सकती है. So आपको ज़्यादा approximation ना करते हुए you need to come to I should say the accurate value. जैसे हमने अभी कैलकुलेट किया, it was 5.8, वो आती 5.8 तो आता ही आता. ये 5.5 का जो सिनेरियो है, yes you can say कि आप either 5 भी ले सकते हैं और 6 भी ले सकते हैं, but make sure कि थोड़ा आप accurate उस पे आए, calculations पे आए. Fine. So let's talk about this particular question. We have reached over here. So over here, what we need to do actually is nothing. It's x into 10 raised to power minus 6. Okay, x into 10 raised to power minus 6, which is equals to this particular value. So I can just take this particular thing. So it's x into 10 raised to power minus 6, which is equals to what? 6.6. Okay, divided by. So it's 4 into 3, 12. If I take 3.14 as 3 and 9.1 as 9, so 4 into 3, 12, 12 nines are 108 basically. And it will be 10 raised to power minus 3. That's absolutely cool and fine. I think there is no issues calculating this particular thing. Any issues, just let me know. I don't believe so. So x is equals to 6.6 by 108. You can take into 10 raised to power 3. You are going to get the answer. When you will actually solve it, okay, if I just talk about solving the answer, what you are going to get is, if I just talk about, the answer will be, it's 0.061 into 10 raised to power 3, which means your answer comes out to be 61. Okay, so this is the approximate answer. Yes, Aakash, you are right. 58 will be the accurate answer. So over here, if we go with the approximation, our answer comes out to be 61. But here in case, if I just go with the accurate answer, it will be 6.6 by 114 basically into 10 raised to power 3. And now when you solve this, we are going to get our accurate answer, which is 0.0578 into 10 raised to power 3. Okay, which is 57.8, which is equals to, this is our accurate answer, 58. So यहाँ पर मैंने भी कुछ ज़्यादा ही approximation ले लिया, but yes, आप थोड़ा सा approximation लेते हुए you can go ahead with this particular thing. 58 will be the right answer for this particular question. 58 होगा, x का जो value होगा, it will be 58. Well, we calculate out 61. 60 भी आ सकता है. So इतना तो I feel JEE थोड़ी रियायत हमें दे दे. क्यों? है कि नहीं? Yes, absolutely. So it's actually 58 the accurate answer. Well, approximate answer अगर आप बात करें तो 160 होगा उसका. ठीक है? Done. Well, this was all from my side for this particular chapter, structure of atom. Hope you have actually enjoyed the session solving the questions of structure of atom. And in this particular whole one day, at 3 p.m. you attended the theory session. At 5 p.m. you attended the question session. So I believe it was really valuable for all of you guys. Hai ki nahi? Yes. So well, dear ones, the upcoming session is basically at 6:30 p.m. of mathematics today herein. Fine. Well, this was all from my side. Thank you for joining me. Fine. And yeah, we'll be meeting you soon tomorrow sharply at 3 p.m. with one short series of which particular chapter? It's basically thermodynamics. And be there, do not miss that particular session. Okay, bye bye dear ones, and be in your good health.